Okay, so let's start. Good morning, everybody, or good afternoon to some of you, and welcome to the Reuse Company webinars. You will be muted during the webinar, but if you have any questions or comments, you can use the questions section, and we will answer all your questions at the end of the webinar. If you have any technical issues, please use the questions section or send an email to support@reusecompany.com. The webinar will be recorded, and in a few days we will send you the link to the recording. Raising the ante, high quality models as the only way forward after high quality requirements. My name is Cecilia Carlson, and I will be hosting today's webinar. With me, I have Jose Fuentes, Chief Sales Manager at the Reuse Company. This is the table of contents for the webinar. First, we will have a short presentation of the company and the presenter. Then Jose will explain the need for early verification of models. Next, we will see the rules for model-based systems engineering. And after that, we will take a look at some metrics in Arcadia Quality Studio for model-based systems engineering. Then we will see a live demonstration, and finally, we will have some time for questions and answers. So first, a few words about the Reuse Company. The Reuse Company was created in 1999 as a spin-off from a university in Madrid, Spain, by system and software engineers. Our headquarters is in Madrid, but we also have an office in Stockholm, Sweden, and a delegation in Tokyo, in Japan. In 2022, we are planning to open an office in the US. Our mission is to promote a reusable, scalable, and global solution to a smart and interoperable systems engineering environment. And we do this by offering a semantic knowledge-centric approach. The Reuse Company is also called TRC. We like to say that it's easy to remember if you think of T like in traceability, R like in reuse, and C like in calidad, which means quality in English. You can also apply these concepts to other topics. The Reuse Company is a tool vendor, and we are specialized in the application of semantic technologies and artificial intelligence to improve the digitalization of the systems engineering life cycle. Our presenter today is Jose Fuentes. He's the Chief Sales Manager at the Reuse Company, and he is the former product manager of the Systems Engineering Suite. He has the INCOSA CSEP certification and is graduated in the INCOSA Institute for Technical Leadership. Jose is an active contributor to the INCOSA Guide for Writing Requirements. He's certified in ITIL and is interested in product management, business analysis, and risk management. So let's start with today's topic. Good morning, Jose.
Good morning, Cecilia. Can you hear me well?
Yes.
Okay, so thank you for this introduction. In fact, I'm very excited today with this webinar. I have been presenting webinars over more than 10 or almost 15 years. But now I'm very happy that because all those webinars were around the topic of requirements, quality. Now we are changing gears a little bit with the topic of quality, of course, but not for requirements, but now also for models and model-based systems engineering. So let me start with this idea of the need of early verification. I think I have been also used this very same chart just to speak about the need of early verification in the field of requirements. It is pretty much the same when speaking about models, but for those of you who could be newcomers, for us, this picture has been taken from the INCOSA Systems Engineering Handbook, just representing as an average how much of your budget for a project is devoted to the different stages of the project. Of course, after the concept, it is just after the conceptual phase, it is just that only a few amount of this budget is consumed. After the design phase, it is also just a very little, 15% of the budget. However, even if we have only put in action 15% of our budget, by means of the decisions that we take both in the requirements phase, conceptual phase, and in the design phase, the number of decisions we have taken is committing 85% of the overall cost of our project. That's why it is so important to take care of the work products that are generated in these early stages of the project, right? If we move a little bit forward to this other chart, then we speak now not about cost, but we speak about errors and failures, right? And this chart is telling us that the phases in which we normally commit more errors is, of course, first the requirements phase, but also design phase, right? And what is even more impacting the overall cost and the overall success of our project is that it is not normally until the test phase, and in the worst case until the operational phase, where we realized of those errors and we fixed those errors. So the most we can invest, the more we can invest in the early detection of failures in the requirements and failures in the design, the less rework we will find at the end of the project, and the more happy we will be, all of us, the happier we will be, right? And this is, as I said, the typical introduction for my webinars about requirements, quality. But now, just focusing more on the topic of models, I wanted to start by using this quote by George Box. All models are wrong, well, but some are useful. So I think I first heard this quote many years ago. And from that moment, I do believe that he was fully right. Even if George was not a systems engineer, he was working in the field of statistics. And of course, in this field, there are a lot of models as well. But however, this quote has been applied to design and models and model-based systems engineering since many years, right? So if we follow with George's quotes, then we can move forward a little bit and say, okay, and, we can ask the practical question is, how wrong do we have, the models have to be in order not to be useful at all? So this is the question, right? And that leads into the topic of models quality. And of course, the idea of investing on the quality of models through early inspection of those models, and hopefully with a little bit of automatic inspection of those models, as we will see today, is key for ensuring useful models and thus the success of our systems and our projects, right? So this is the idea that I would like to embrace during today's webinar, right? So early verification and, if possible, automatic verification. And what can we? How can we define the concept of quality for models? We can see this aspect from two very different standpoints. So the first one is, of course, the conformance with requirements. Normally, in systems engineering projects, we will start with requirements. It could be both high-level business requirements or stakeholder requirements, system requirements. So we do begin with the concept or by the definition of some requirements, and then these requirements turn into a model by means of a kind of transformation. So conformance with requirements just tell us that we must have this transformation properly done. And this topic has been addressed in our tool RQA many times in the area of checking consistency and completeness between requirements and models. This is something that if you are a regular follower of our webinars, then perhaps you have attended those webinars. If not, please do visit our webinar section in our website for more information about consistency between requirements and models, and the completeness also, which is comparing the information in the requirements and the information, which is now represented as a model, right? So the first standpoint was that the conformance with models. The second one is, of course, fit for purpose, which has to do a little bit more with the notion of validation, which is where the purpose and the real need is established, right? Because at the end of the day, different models can implement the same set of requirements with different degrees of satisfaction for the end users, and this has to do more with the notion of validation. In today's webinar, we will focus more on the idea of verification, like the satisfaction of some established set of rules for models. So if I take this picture from the INCOSE guide for writing requirements, and also the needs and requirements verification validation guide, then you see all those stages, starting with the needs at the very left hand side of the picture, and the final system, like the 3D box to the right of the picture. In between, you have all those transformations that I was mentioning before, the transformation of the different levels of requirements and the transformation into design, right? And in here, you can see, along with all those horizontal arrows here, you can see some other arrows up and down, right? The arrows up are representing, the yellow ones are representing the validation, as I was mentioning before, the fit for purpose, which is contrasting or checking whether or not these requirements, design, and at the end of the day, the final system is addressing the needs from every stakeholder, not only the end users or the regular users, but every stakeholder involved. And but as I said, we will focus today on verification. So verification for requirements is what we have been doing for quite a long time. It is represented by these green arrows here down, where we can establish the so-called organizational requirements definition requirements. So it seems to be a little bit strange to find the word requirements here twice. If you replace the final requirements by rules, organizational requirements definition rules. So the idea is, this verification addresses the question, are my requirements following the rules that has been defined on how to write a requirement? So this is the key question. When it comes to models, if we move forward a little bit, then you can find two arrows for verification. Of course, the first one, as I was introducing in my previous slide, was is this design conforming with the requirements? So that means, is this transformation correctly addressed? So this is this verification here. However, there is also another verification arrow, this green one, which is asking a similar question that in requirements field, which is organizational architecture and design. If we split this modeling into these blocks that as normally is done following the processes in the INCOSE guide and some other guides. If we speak about models in here, so organizational models, definition, rules. So are my models following the rules that has been designed or has been set up or has been agreed upon in my organization on how a model should look like? So this is the question that we will address in today's webinar. So are we following a specific set of rules when we create our designs? And of course, here the idea comes again to the notion of inspection of the quality of our models, right? So as of course you know, and perhaps you have enjoyed or suffered, there are different degrees of inspection for every artifact in the life cycle of our projects, from the very open and quick and let's say less formal pass-arounds or peer reviews or walkthroughs, to more formal ideas like inspections or preliminary design reviews or critical design reviews or external internal audits. So all those inspections or types of inspections range in the level of formality But regardless this level of formality, every single inspection you perform is, let's say, expensive. Of course, the less formal are less expensive. The more formal are by far more expensive. Normally, the way we address all those types of inspections is early and frequent as possible, and as early as possible. Informal inspections first, and followed by less frequent formal inspections, where the previous informal inspections are telling us that the model is in good shape, let's say. In all of those inspections, but especially in the earlier ones, having a tool to do some automatic checking for some specific rules will really pay a dividend. Of course, this is not everything you have to do. Of course, you will have to take human brains to inspect those models. However, there are a number of rules that are time-consuming for a human cost, let's say, for the cost of an engineer, are very time-consuming, and can be automatized with the help of a tool. And this will be the focus of this webinar, right? Just before we get into those rules and the tool to execute and to perform those rules, let me just finalize this section with 3 quotes, just for those, or to clarify some concepts, because there are, of course, as perhaps you know, there are a lot of misunderstandings in the concept of what is system verification, or what is requirements verification, or models verification. So the notion of verification sometimes is understood like comparing the final items in the, let's say, in the right-hand side of the V with items in the left-hand side of the V. However, even the System Engineering Handbook is telling us that the verification process can be applied to any engineering element that has contributed to the definition and realization of the system itself. So that includes the verification of system requirements, a function, an input-output flow, a system element, an interface, a design property, or even a verification procedure can be verified, right? So this is telling us the notion of everything can be verified, including all, of course, the elements that you create in the left-hand side of the V. The second quote is also coming from the handbook, telling us that the purpose of the verification process is to provide evidences that no error has been introduced at the time of any transformation of inputs into outputs. It is used to confirm that this transformation has been made right according to the requirements and selected methods, techniques, standards, and rules, right? So this is the idea of today's meeting, how to define rules and how to automatize those rules for models. And now my final and short quote is coming from the Needs and Requirements Verification and Validation Guide, which is a lovely outcome of the Requirements Working Group, in Course Requirements Working Group. And it is telling us that when using models and simulations, it is important that they go through verification process to ensure that they are formed correctly, as well as a validation process to ensure that they correctly represent the entity that they are modeling, right? So I think this is wrapping up what I've been presenting so far. So let's move forward a little bit into examples of rules that are normally used in most of our customers when we're verifying models. Rules like name of the elements that shouldn't be empty for most of them, and name of some kind of elements that should follow a given template. Sorry, like for instance the interfaces that should start with lower I, followed by capital letter, for instance. Avoiding misspelling, both in the names and in the descriptions. Descriptions that shouldn't be empty or should follow a given template, like the typical template in a use case, as you will see later. Misspelling here and there, actors or logical systems that should be contained in at least one diagram. The typical error that we all commit from time to time, where we create an element in a diagram, then we remove from the diagram, but we keep it in the model, or more rules like the 7 ± 2 in the decomposition of systems or functions, stakeholders that should be always connected, associated to at least one use case, but never to other stakeholder or states that might have always one incoming and one outgoing transition. So these are the kind of rules that are normally applied in the verification of models. So the idea is how now we have evolved the RQA tool now to tackle the notion of checking the quality of models. And this is what we call RQA for model-based systems engineering. So we have done following the typical notion that we follow in RQA about metrics, right? So we have elaborated a number of metrics. If you know RQA, then perhaps you are aware of the distinction between non-parameterized and parameterized metrics. In our approach, we have these two types of metrics where the non-parameterized, in those non-parameterized metrics, the algorithm is already there. There are no means of influencing the way the algorithm for the metric works. Like an example could be misspelling. Misspelling is misspelling. You cannot influence the way misspelling is working, right? However, in the so-called parameterized metrics, and I do believe that these are the more powerful metrics that we have. That's why I have included this strong arm picture there, or icon there. All those parameterized metrics gets as an input one or more parameters. With these parameters, we can influence the way the metric is executed, right? In the RQA, you will see this as the icon for our metrics. The green ones are the ones that are non-parameterized, while the blue ones are the ones that are the parameterized. Both non-parameterized and parameterized might have as a first block a filter, which is in the case of RQA for model-based systems engineering, the filter is what is the type of element where you want to apply your metric. So for instance, suppose that even for the non-parameterized, you want to apply a spell checker for the name of, I don't know, of blocks, for instance, right? The idea is that in the filter, you can say, okay, I want to apply this for a block. So you select the type of element block as the filter, and then the rule will work for only for blocks. The other example here is, okay, I want to see that the description of the use cases is not empty. Then in this case, you use a use case as the filter. It is important to mention that when we speak about, for instance, in the filter, and as you will see later, in some of the types of metrics, we speak about the type of an element. This filter could be just the type, right? Class, actor, whatever, or could be a stereotype. If you have your own profile, or if you want to use the standard stereotypes coming with SysML or UML, and then you can either use type, the name of a type, the meta type, let's say, the meta class of an element, or the stereotype, right? So this is the filter. As in the case of the metrics for requirements, every single metric in RQA is having a number as a result. So, for instance, very easy. The misspelling metric. What is the number that we get as the result? The number we get is how many misspelling errors we have detected, right? Or other metrics, like, for instance, metrics to count how many associations are there between, for instance, between actors and use cases. The result is a number as well. So the result of this metric is how many, right? And then what we can do is, by means of the so-called quality function, which is exactly the same notion as when analyzing the quality for requirements, then we will be transforming this number into a high quality, medium quality, or low quality aspect, right? In requirements, we used from time to time the notion of medium quality. In models, I think in all the rules that we have implemented, we find high and low. We are not finding a point in between. So the 2-star icon will never be shown. You will always find 1 or 3 for individual metrics. Of course, when we combine all the metrics as the result for a given model element, yes, of course, you will have the possibility to find 2 stars, right, in this average computation. So in the case of, as I said, counting how many associations are there between actors and use cases, of course, if there is no association, 0 association, then this is low quality. If we have 1 or more, then it will be high quality. We can find the opposite quality function, for instance, in counting something that is forbidden, right? So by means of this, we are enforcing that every actor should always have a connection to a use case. In this other metric, this is another screenshot. In this other example, what we are counting is how many associations are there between actors. Normally, associations between actors are forbidden, but the tools, the modeling tools, normally allows us to draw associations between actors. But the tool RQA can count how many associations are there between actors. If there are 0 associations between actors, then everything seems to be okay. If there is 1 or more, then this actor is not has not been designed properly, right? So most of our rules, the quality function for most of our rules will be eventually a binary function. 0 okay, 1 or more is not okay, or the opposite. However, you can also find more strange quality functions like the one to implement the typical rule 7 plus minus 2, as I was mentioning before. So, for instance, in the decomposition of a PBS, normally what we find is that if the number of direct children of an element is not following this 7 plus minus 2 rule, then perhaps this is too complicated as to be kept in the brain of the engineers. And similarly, if we decompose one element into another one element, or one element into only 2 elements, then perhaps this is not enough as to perform a following step in the decomposition, and we should keep as we were without further decomposition of this element, right? So this is as I said, the typical 7 plus minus 2 rule. And then how can we implement this rule? We can implement the rule saying that if we have if we have no children, then it means that this element is a leaf in our tree. This is okay. If we have I think there's a mistake here. It should be 1. From 1 to 5, then the level of decomposition is too short, so it is not following the rule. If we have between 5 to 9, remember that this limit is open, so it is 5 to 9, and then the quality is okay. If we find more than 10 children, then perhaps, as I said, the composition is too complex, and this would be hard to keep in mind, right? So this is another quality function. This is perhaps one of the few ones that are more complicated in the notion of more elements in the function. Normally, the functions are binary, 0, 1, right? So the metrics in detail that we have implemented, as I said, we have metrics to detect that the text should be empty or not. In fact, what we do is we count how many characters are there in the matrix. So it is not only to detect that the name is empty. We can also, as you will see in the demo, it is also can be also used to detect that if you have a rule saying that the name of a block should not be less than 3 characters, then you can implement these kind of rules for the text and for the description. Also, the detection of misspelling errors in both in the text and in the description. The idea of missing the type for a port. This is another rule that we have implemented. Or counting how many stereotypes are there. There are different types of elements where we, using a specific profile, we always want to be a stereotype and not just the plain element itself. So we can implement these rules. Now, moving into the parameterized metrics, we find this one, as I was mentioning before, just to check whether or not the name or the description is following a specific pattern. We can use this to check the name of our interfaces and ensure that those names start with lower I followed by a capital letter, or just to check whether or not all of our use cases is following the typical pattern, including the precondition, the main flow, the alternative flow, and the post condition, for instance, right? Then one of the most powerful rules is just to to ensure what is the owner of an element. So we can implement this rule to ensure that the logical system is contained in at least one diagram, right? So in here you can see the actor or the stakeholder pilot. This is of course part of the model, but it is not part of my diagram, right? So by means of this rule, we can detect this kind of things. So a logical system or an actor that is not contained into a diagram. We have now the opposite, right, which is owned elements. So we can count how many elements of a given type we have for any of the elements that we analyzed, right? We can use this to find, for instance, empty diagrams like in this example, this state diagram without any state and without any transition. So by means of instantiating this metric, by the way, as I don't remember if I have mentioned that, you can instantiate the same rule as many times as needed with different parameters. So this makes that eventually the number of rules implemented is almost infinite, right? So you can check empty state charts or empty PBS diagrams or whatever. By the way, in the filter, you can always introduce more than one type of element. So with only one rule, you can have a metric to check that PBS state charts or any other kind of diagram is not empty. You don't have to create one. If you don't want, you don't have to create one individual metric for each one of the checks of emptiness that you want to implement, right? So empty with this metric, empty state machines, empty diagrams, or even suppose that when you implement an interface, you always want to have operations in this interface. So by means of this metric, you can check that. Or as in this other example here, in the right-hand side of the screen here, sorry, you find a number of functions, and each one of those functions is having one or more pins, right? But the remove all, which is another function, is not having any pin, right? So by means of this metric, you can detect functions without pins, right? Another very powerful metric is the one that is counting relationships between elements, right? And we can instantiate this metric with additional parameters like what are the type of elements you want to check, what is the type of relationship you want to follow, and if it is from or to or both the direction of the association. By means of this metric, we can check things like, for instance, as I was mentioning before, we have this strange association between two actors. It should be forbidden to have associations between actors, right? So by means of this metric, you can count. You will filter. In the filter, you will use the type actor. In the type of relationship to follow, you can use the association, meaning that of course you can find generalizations between actors, but not associations. So in the filter, in the first in the parameter, the first parameter is the type of the relationship. So the type is association, and the second parameter is the element at the other side of the association. So we count how many associations are there between actors and other actors. In checking the quality for both of these actors, you will find a number of 1, and this 1 is transformed by means of the quality function into poor quality for this actor and also for this other actor, right? But we can also instantiate this very same metric, but now changing a little bit the parameters. So the filter is actor again. The first parameter, the type of the association, the type of the relationship is association again. But now the second parameter is different. That now it will be use case. So by means of that, we will count how many use cases are associated to a given actor, right? In the case of this one, the number will be 2, and then this by means of the quality function will be transformed into high quality. In the case of this one, the number of associations going out from this actor to use cases is 0. so represented by this question tag here, and that this will end up in poor quality for this actor, right? So this is the idea of this metric. And then we have other metric to check coherence in relationships. This has been first applied to flows between the pins in functions in a function flow, right? So that we can validate the direction of the flow, we can the direction of the pin, we can validate the stereotype, we can validate the type and the name, right? And we also have in mind the different or flows between different levels of abstraction, right? An example is given in here, where we find some functions here at the same level. So these two functions are represented at the same level, and this is a pin representing the upper level of the function, right? So in this case, this is, by the way, this dialog box here is representing this pin, the one that you see it is selected in here, right? So in this case, this pin is an out pin. This one is another out pin. So out and out at the different levels of the hierarchy, out and out is okay, right? So this should be represented as good, at least for this metric, a good couple of pins, right? However, if you see these ones, this is an out pin, this is an in pin, right? So at the same level. So out and in at the same level. Sorry, this is out and this is out. Both are out. Out and out at the same level is poor quality, right? So this is what the kind of things that you can check with this metric, together with, as you will see in the live demo, checking the stereotypes. Normally, you will find that the type and the stereotype of both pins connected by means of this function flow has to be the same stereotype, right? If there is a mismatch in the stereotypes, then the RQA will detect this flow as a wrongly created flow, right? And then the final type of metric, wow, with two arms in here, is the so-called custom code metrics, meaning that if you are not, if the number of parameterized metrics we have offered in an RQA is not enough for you, you always have the possibility to write the code for your own metric, or you have the possibility to ask us to implement a metric for you, right? So before we move forward into the live demo, just to mention that this demo will be using Rhapsody as the tool for my demo, but everything that you can see here can be also applied to other tools like Cameo System Modeler, Capella, Enterprise Architect, Papyrus, or other tools that are not UML SysML tools, but more in the field of simulation, like MATLAB and Simulink, OpenModelica, or Altium Designer. If you were using other tools that are not in the list and that you are interested in checking out our RQA for MBSE, please let me know, because implementing a new tool in our tool, in the next version of our tool is very, very easy. So we are not that far. Just let me know. So before we go to the demo, and for those of you aiming to start as soon as possible with this RQA for MBSE, let me tell you that this capability is a brand new capability included in the System Training Suite version 22. This version is to be released, is planned to be released in June 2022. So just wait a couple of months or a little bit less. And the way to implement those rules is by means of a library, as we normally do also with quality rules for requirements. What we will do is we will develop a library that will be publicly available in our library section of our website. So you just have to open KM Knowledge Manager to import this library into your current database, and just open RQA to assign this catalog of rules into your models. And of course, if you want to, let's say, customize a little bit the rules that we offer in this library, you will see in my first demo, in the use case number 1, that I will show you 3 different demos. In the first one, you will see how you can even you can edit the rules, or you can even, as in this example, start from scratch. So without any further ado, let's move into these 3 demos that I mentioned. So the first one is just to show you how you can start from scratch, and you can come out with a number of quality rules, right, for models. Oops. Okay, here we go. So this is the RQA in version 22, right? And I am creating a new metric template, which is a catalog of rules. It is fully empty. So I named these rules for model base with whatever description. And then, as you can see, there are no rules. So I can start with all those green or blue ones, remember, non-parameterized or parameterized metrics. So we start with this very first metric just to check the length of our requirements, right? This is a non-parameterized, but even for non-parameterized, remember, you can establish the filter. You can establish the filter by writing down the name of the element or a stereotype, or you can also click on the magnifier to select from the list that we offer, right? So in this case, we will say that if the length is less than 3 characters, then it is too short, right? If it is from 3 to 50, it is okay. If it is over 50, it is starting to be a little bit too large, right? So this is the way we have configured this metric. Of course, as I said, you can always customize and come out with the rule that you want to implement. So the second metric is now a parameterized metric. The filter is, I want to apply this metric to logical systems. As I mentioned before, you can type freely the name of the element, or you can select from our list. So I want to apply this to logical systems. And now, as a first parameter, I am using the notion of the diagram PBS, right? So I want to count how many sub-elements are there in a PBS, right? Now in the configuration, I move forward a little bit because we are a little bit out of time. So in the configuration of this rule, we want to ensure that there is at least one element in the diagram, right? So this has been the configuration. So more parameterized metrics now based on relationships between elements. Now to implement the rule 7 plus minus 2, where as the first parameter or as the filtering, I want to count the number of elements of a logical systems, right? Following associations. Remember that association is the father of composition. Of course, you could also pick composition, right? Between logical systems and logical systems, right? So this is what I want to count. How many relationships are there between logical systems, right? Since this is the 7 plus minus 2 metric, then the quality function it will be having 3 levels, right? As I was mentioning before in my slide, if it is over 10, it is too much. If it is less than 5, it is too little, let's say, right? So this is the way we have configured this in here, right? So, and of course, if it is just 0, it is a leaf element, and this is also okay, high quality, right? So this is the way we have implemented also this metric. And the final one will be checking for ports, for the direction of the ports, where, of course, the element to filter could be just a port or could be a specific subtype. As I was mentioning, we can use types of elements in the filtering, or we can use stereotypes. So this is an example of how to use stereotypes. We want to check the coherence only for these 3 stereotypes of the flows, right? And the element, the relationship is the flow, and we want to check just the direction. There are other options like checking the type or checking the stereotype, but in this case, we will check just the direction. And that's all. So now the metric template is ready for you to start analyzing the quality of your models. So this was my first video. In the second one, we will be applying these rules and other rules to one of my actual models, right? So I connect in RQA, I connect to my model. This is Rhapsody, as I said. We can also do similar analysis to other elements. So this is now RQA version 22 connecting to a model. You can see the model represented in the tree, and you can see in the right-hand side also the diagrams. But remember, this is not a modeling tool. So this diagram is just a screenshot we have taken automatically. Automatically, when we parse the document, automatically we can. There is a checkbox that you can enable. It is a little bit more time-consuming, but then in the parsing, we can also get screenshots, let's say, from the actual diagrams, right? And this is what we saw. But remember, this is not. You cannot find the palette to add elements or remove elements, right? So this is just a frozen visualization of your elements, right? But in the tree, you have the rest of the elements, or you can move now into another view, which is more similar to the one perhaps you know of RQA. And in here, we are selecting which is the catalog of rules that to be applied. Here you can see all the rules that are applied to this document. In this example, only 13 rules have been created. So let me show you how to execute those rules in the actual model, and of course, let me show you some results. So the way to execute is exactly the same as in RQA for requirements. By the way, this is real time. This is a small, very little model with only 270 elements on it, right? But it took us only 5 seconds to analyze the one, right? So let me show you some of the rules. First one, I was speaking about the length of the names as one of the more basic rules, and I have a block called, or logical system called O1. O1, in my understanding, it is too little. So as you can see here, when I open O1 in RQA, then you see two rules here that has been violated. The first one is with the value of 2, the length has given us a value of 2. This is too little, too short to be the name of an element. So this is why among the 13 rules that are here, the 2 ones that are violated by this element is first one, it is too short. Second one, O1 is misspelled. O1 means nothing. It is not in an English dictionary. It is not in our ontology. So these are the 2 rules that has been violated, right? And the tool can show this for you. The rest are even 3 stars or has not been applied to this element. So, for instance, the rule for the pins and the in-out pins doesn't apply for this. Then fine filter, another logical system, but in this case it is isolated. It is not connected to any other element. So the tool can detect these kind of things as well. So you can use the search box, fine filter, and then you see poor quality for this element, because mainly because it is isolated, right? Which is this one. So this is the rule that we are violating. More things to show here. Yeah, let me show you how we can detect that the oil tank is decomposed in only 3 sub-elements, and it is not following the typical 7 ± 1 rule, right? So we open the logical system. And then we can see that the rule has been violated because we get a value of 3, as you can see here, and 3 is not in the block of 7 ± 2, right? By the way, whenever you see a name, an element represented in RQA, you can click on it, and as you can see, the tool will open Rhapsody for you and would select the given element automatically. Now let me focus on use cases and actors. So we have a fuel operator, as I was showing you before in my slides. This fuel operator is not having, the fuel operator is connected to another stakeholder, an actor, and this is something that we don't want to find, right? Fuel operator is connected to tank operator, and this is poor quality. That's why we have only 1 star, and this is the error for this actor. Of course, also there are other errors like the description is empty and some other errors for this actor. Now we focus on the other actor here, the operator itself. Then it will be telling us first that of course it is connected to the other stakeholder, which is not correct. But we also have a value of 0 in terms of how many use cases are connected to this element. In this case, it is 0. This is not what we expected, and that's why we have poor quality, right? Okay, let's move forward, and then we can find this other pilot, which is not part of the diagram, right? Of any diagram. So this is another error we have detected with RQA. If we move to pilot, then of course we will see that the pilot is not part of any diagram, and this is representing an error. Of course, since it is not in any diagram, it doesn't have either any connection to any use case, and this is another error that has been detected. Also, the description is empty. So all these kind of errors has been detected for this actor, and that's why it is ranked as poor quality, because it is not meeting the rules that we have created for it, right? Okay, more things. Okay, this is now let's move into the field of flows and these kind of things. So this is what I was mentioning before. There are 2 pins in here. So this is exactly what I was showing you in the slide. These 2 pins are connected by means of this flow. However, the direction is out and out in both, and this is detected by the tool. Right? Now we can see also that in this other flow, the direction is okay. As you will see in a minute, this is out and the other one is in, so the direction is okay. So what is the issue in this? The issue is that the outgoing is having a stereotype of hydraulic, while if we go and select the other end of this flow, which is this one. So you can see that the stereotype is pneumatic, right? And this is what is detected by the tool. So the direction is okay, out and in. However, the stereotype is the wrong or is not is mismatching. So the tool detects the issue in both elements. So either if you click on the left or in the right, the same mistake will be highlighted, right? Move forward a little bit. So we have 2 use cases. The first one is following the typical template that I was mentioning before. However, the other one seems to be following the template because the template is there. However, the content is empty. So the template is there, but it is fully empty. So both, if you were not following the template, or if you follow the template but there is no content in the elements, especially in the regular flow, this is the one that we check that shall not be empty. Then that's why if you click on the first one in the RQA, the tool will tell you that this metric is okay. So the template is followed by the use case filter. This is what RQA is telling us. However, if we now go for refuel, okay, here we are. Then and we select this particular metric, then we will see that the template is not followed, or it is followed but it is empty, which is detected by the same metric, right? Exactly. Right. So this is the issue. Okay, let's go now for the last. We are running out of time. Last use case. It is a very short one. Before we get into the Q&A section, and this is just to show you about reporting, right? So in this case, we have taken, or the tool, as in the case of RQA for models, the tool allows you to take snapshots of the level of quality. So every time you analyze the quality, you can take a snapshot, and at the end of the day, or at the end of the project, or whenever you wish, you can compare how the quality is evolving along the time, right? So I have just analyzed the quality for my elements, and then I create yet another snapshot. Okay, and now I can click on this evolution scoreboard, and then what I see is we will have to investigate the reasons why the level of quality is dropping from 100% at the beginning, and now we have less level of quality, right? All these quality results can be exported into PDF or Word or Excel format in this template, telling you how many elements you have in high quality, medium quality, low quality, and for all the rules that has been violated, how many elements are violated, right? So you have a bar for each one of the rules implemented, and in this bar you have the number of elements that are not applicable, or in green, not applicable in gray, in green, high quality, or in red, low quality. And then in here you have all the elements that has been reported as low quality. You have the name of the element, and you have the metrics that has been violated for this element. Okay, so I think that's all. We move forward now, get into the Q&A section. Cecilia, I think you are there.
Yes, thank you very much, Jose. Jose will answer your questions in a minute. So if you have questions for him, please write them down in the questions section. Meanwhile, I will give you some information about our next webinar. It's called Taming the Systems Engineering Life Cycle Using Connectivity and Interoperability, the SES Engineering Studio. The SES Engineering Studio is a new tool designed to orchestrate the development of all kinds of systems, hardware, hybrid, and software, by connecting and enabling interoperability between an unlimited number of existing systems engineering tools like requirements management tools, MBSE tools, simulation tools, risks management, RAMS management, MS Office, etc. It also provides full support to technical management, as in ISO 15288. During this webinar, we will present the core concepts of this approach and introduce our new tool, SES Engineering Studio, for you. The dates for this webinar are the 10th and the 12th of May. So let's see if we have any questions. Yes, can you check the description of an element for specific information?
Yes, I think I presented this in the webinar. You can check the description first for emptiness. You can create a rule to say, okay, this is empty or not. But also by means of regular expressions. What I didn't show is the definition of the regular expression. But of course, if you want to check if it's empty or not, it is very easy. It takes just a second. If you want to check a specific content, like the template of the use case, then you must learn a little bit about the definition of regular expressions, right? It is not that hard, but of course it takes a while.
Okay, thank you. We have no further questions, so thank you very much, everybody, for attending. If you have any additional questions later or want more information about our tools, don't hesitate to contact us by email to contact@reusecompany.com or through our website, reusecompany.com. Thank you very much and goodbye.
Thank you. Goodbye.